This is a completing the square question, but we have a coefficient that's not 1 in front of the x squared, which makes it a little bit trickier. First thing to do is then set it up. Take out the coefficients from both the x squared term and the x term. You can just leave the 11 by itself, it's not going to affect anything. And then complete the square on this bit inside the brackets. So we're going to take the x, we are going to have this number here and square it. So at the moment this would give us x squared minus 3x plus 9 over 4. So I need to minus 9 over 4, so I haven't changed anything. Close the bracket, the square bracket, plus 11, and I'm nearly done. I can then expand this back out. Okay, and I've got this bit here. Then I'm gonna, sorry, that's not very good, 2. Then I'm gonna minus 4 times 9 over 4, which is minus 9. Okay, and then just finally tidying it up. I'm gonna get this. Part 2, only 1 mark. State the number of real roots of the equation that we've just basically completed the square for. And we can see that because this is always greater than 0, it doesn't have any roots. This graph, if we plotted it, would be above the x-axis. So we can say that there are 0 real roots. Finally, explain fully how the value of r is related to the number of roots of the equation this in completed square form, where p, q, and r are constants and p is greater than 0. Well, we've just spoken about when r is greater than 0, because that would mean that it's above the axis, and then we get 0 real roots, just as before. What happens in other cases? Well, there's when r is equal to 0. If you then solve this equation with it gone, you can divide through by p. You can take a square root, and you will just get that x plus q is equal to 0, and you'll just get x is equal to minus q. That basically means there's one solution. We say that there's one repeated root. Technically, I think according to the fundamental theorem of algebra, there are still 2 roots. It's just that they are equal. But this is what the sort of syllabus expects you to write in any case, one repeated root. And then finally, we've got that r is less than 0. Now, if I solve it, when I back to here, if I was to take a square root, then when I get this r over to the other side, it will become positive. I take a square root, I get 2 solutions, and that's my answer. R is less than 0, I get 2 distinct roots. That means they are not equal. And that's the answer to this question, 2 marks.